Across this session, we'll ask the question, are eco-evolutionary dynamics a general phenomena, in which case we should expect them everywhere, or are they a special case limited to some particular situations? Hutchinson articulated the idea that evolution fine-tunes the ecology. However, evolution is on a slow time scale, while ecology happens rapidly. This has been the dominant paradigm since. Another paradigm was presented by Pimentel. He presented the case for population genetic feedback. An understanding of ecology requires a simultaneous understanding of rapid evolution happening at the same time. A modern definition of these eco-evolutionary dynamics is narrowly defined as reciprocal interactions on a contemporary time scale of these ecological and evolutionary dynamics. To rework Hutchinson's classic analogy, ecology and evolution are actors on the same stage. In the 1990s, Peter Abrams, who we'll hear from next, developed theory as to how evolution introduces time lags into population dynamics. In his work, the evolutionary dynamics responded to the ecological dynamics and vice versa. A now classic empirical work was published in 2003. Gregor Fussman, who will be talking later, and others experimentally turned on and off evolution in a rotifer algae system by including a single clone of algae or multiple clones of algae. When evolution was turned on, the population dynamics were radically different than when it was turned off. This foundational empirical work led to a flurry of research looking for examples in which ecological and evolutionary dynamics are intertwined. For example, this past June, work on soil mites showed that harvesting resulted in the evolution of life history traits that rescued a population that would otherwise have gone ecologically extinct. In 2011, an American naturalist symposium asked, what is the evidence in nature for a truly reciprocal interaction? This work was recently published in 2013. Currently, the count's very few because of the difficulty in doing these experimental manipulations. This question arises from skepticism that perhaps this line of reasoning represents just a special case. The flurry of recent work is simplified work, it's lab-based work, genetic variation perhaps is being artificially inflated. There are very few cases of full reciprocity. Many studies represent only one dynamic responding. The skeptic might argue that just based on first principles, ecological dynamics should be faster than evolutionary dynamics, this classic argument. Perhaps this is a semantic argument, arguing over the definition of a term. That gets tiring and often makes little progress. I suggest that a potential solution to a semantic argument is Brahms. In Brahms' variations on a theme, the music opens with a melodic phrase, which is then modified throughout the piece. Those variations that follow make sense in the context of the theme. I think we have a precedence for this. There are few empirical examples of constructs like coevolution and metapopulation if strictly defined. But having these organizing constructs help us make sense of the variations we observe. It's almost Platonic in having an idealized system. We observe Plato's shadows on the cave wall and it helps us organize the world. It's a practical way of organizing a set of strictly unique ecological situations. Variations on a theme may help us to make sense of eco-evolutionary dynamics. There may be very few strictly defined examples, but lots of examples that contain enough elements to make it a useful idea. Having the type specimen allows us to organize and contrast what we observe. For example, a recent analysis argues that lots of ecological traits can be parsed as to the percent contribution of ecological and evolutionary dynamics. Another idea advanced by the work of Katja Cole, Ron Bassar, and Joe Travis, all of which you'll hear from shortly, is that there may be lots of stealth eco-evo interactions because of how they might offset one another. It might be happening all the time, and we just don't see it. In fact, if it's this general, perhaps we need a new null. Maybe the new null is the expectation of eco-evolutionary dynamics, instead of starting with the premise that dynamics occur on separate timescales. This hanging question of generality will be briefly touched on by our speakers. Up next is a series of reflections on eco-evo interactions by various participants in the paradigm, and at the end, we'll open the floor for a Q&A discussion.